Thank you very much. Good morning, everybody. My pronunciation of my name was pretty well. Thank you, Christophe. I'm Duncan Verstraeten, a representative of Zaparay. We are a Belgium-based company, and it's all about disinfection. Our technology we use is used to disinfect objects. I hope you all had a good breakfast. I will keep it short and very condensed to have some sufficient time for questions and answers. As I said, it's about disinfection. The technology we use is UVC radiation. That is, as such, not a new technology. It has been used in medical settings already for the first time in 1937. So it has proven its efficiency. What does UVC radiation do? And I all hope you had a great breakfast, because these images are not always the most pleasant to look at, but we are neutralizing DNA and RNA with UVC radiation. So basically, all pathogens, talking viruses, bacteria, mycobacteria, fungus even, are being reduced, are being killed by UVC radiation. Fortunately, UVC radiation is not present on Earth, thanks to the ozone layer. If we didn't have the ozone layer, we would not have a healthy DNA system in our body. Now, our company, what is so unique about it? We are the first company, more or less in Europe, because we haven't found any competition on the specific technology we use. We are the first company who is using exclusive LED as the radiation, as a light source, which is then replacing at the end the conventional UVC lamps. So UVC light, and a light is maybe the wrong word here because you can't see UVC radiation. UVC radiation has been generated for the last 100 years with mercury discharge lamps. And this is where our background in LED technology kicks in. Myself and Mieke Fleur, my right hand, the CEO of the company, we used to work a long time for Barco, and I believe a lot of you will know Barco for the medical imaging systems and also for the military applications they built. So we have had our background in the technology years ago, and it's only recently that UVC LEDs came to the market. So the technology is still in its early phases, but nevertheless, we have built the first devices using this technology. What are the benefits of using LED for UVC disinfection? It's all about the lifetime of your light source, and it's all about the lack of heat. The biggest benefit of using UVC radiation by LEDs is that we can disinfect any object, any medical object, but it can be just any object, without having the risk that the material is being deformed or is being harmed by the presence of heat, as we do not radiate any heat. And besides that, of course, there is an ecological aspect. I'll come back to that later on. And there is a safety system, because as you saw, UVC radiation should be dealt with great caution. Now, our technology in healthcare, what are we providing? We are providing a prevention of cross-contamination, a higher degree of asepsis. Our technology is sustainable. We are reducing the amount of biocides used. And in the meantime, we do not use mercury to generate the radiation. And we can have reproducible results. I'll come back to that in just a minute, why this is so important. So bottom line, using our technology in a healthcare setting is reducing the cost of healthcare in general. Why is this? Because our technology is automated. You do not need a person who has an alcohol wipe or a biocidal wipe to manually disinfect objects. This is an automated process, not involving any labor. So it saves cost. Asking which markets we serve. For the moment, we have started in Belgium. We are a startup, we're 2 years old. We have been backed up by private equity and governmental grants who have funded our research and development. For the moment, we are very active in the world of infection prevention. And this is where the biggest benefit of our technology can be found. And next to that, quite some dentists are also using our devices. If I provide you a summary of where our technology can be used in the ecosystem of infection prevention and sterilization departments. At the left side, you can say there is disinfection by means of biocides, by means of alcohol tissues, alcohol wipes. And on the right-hand side, you have sterilization with autoclaves and thermowashers. Our technology is in the middle. We provide a far more better degree of disinfection than with alcohol and biocidal means. But we do not go all the way to sterilization. And it's a bit that void in the middle where our technology kicks in and comes in as a benefit on top of the current protocols used for disinfection. So currently, we advise our customers to take a look at everything they disinfect in a hospital or in a dental cabinet and be critical about the results they expect of the current disinfection protocols. And based on that input, we provide them a solution with UVC radiation, which is typically always a higher level of reduction. Now, technology is one thing, it leads to equipment, to a medical device, to our devices. The first device we have built and which is on the market already for a year is what we call the Ray 1. It is a drawer system. You can put in any object the size of a MacBook Air, let's say a small laptop, entering the device, starting the unit, it gives you in 5 minutes a radiation of what we call 100 millijoules per square centimeter. That doesn't say a lot, except for those specialists amongst us. But during those 5 minutes of radiation, we have been able to prove that we kill 99.9999% of viruses, and even on gram-negative bacteria, which are pretty resistant to biocides, we obtain a log 5, as we call that, a 99.999% reduction in 5 minutes. We are a technology-based company, so we are constantly evolving and investing in R&D. In the meantime, we have developed a second product, which is going to be launched this weekend on May the 1st. What is the difference is in terms of size, exactly the same, in terms of UVC radiation, exactly the same, but we have implemented a nice piece of electronics, which is measuring the UVC radiation real time, and more important, logging the results. We have been asked by hospitals to provide a proof of radiation for each individual cycle. So this device is equipped with a USB port, and the healthcare specialists, they can download the results of every individual cycle. Talking about results, our devices have been tested, of course, lengthily in multiple microbiology labs, and we are using one lab in the UK, and also the university labs of the universities of Leuven and Ghent in Belgium. Microbiology results are one thing. This has proven the efficiency and the efficacy of our devices. But next to that, of course, you need the necessary certifications and test reports, which we obtained in the meantime. And that concludes my presentation about our technology and our devices. And yeah, it doesn't come as a surprise. We are looking for international value-added distributors to distribute our products globally around the world. Thank you very much, and I'm available for any question.
Thank you, Duncan, for the short and sharp presentation, and also it's very fascinating. One already question from me, how does it work actually with the dentures and like the curvy edges? Is something interesting for me as a not non-expert in this field. How is it possible that it just disinfect all those curvy edges and the dentures and stuff?
Yeah, this is the right question indeed. UVC radiation uses light, and up till now nobody was able to bend photons, so photons go into a straight line, making that shadow, and shadowing is our greatest enemy. So our users are being trained to position the objects inside our device in such a way that they do not overlap, because an overlap gives shadowing, and shadowing does not result in a great disinfection. But how do we ensure that we can radiate the total surface of a device? It is all related to the fact that we have built a matrix of radiation. So the bottom and the top of our device is covered with LEDs, and the remaining surfaces inside our device are using a very special reflective material for UVC radiation. And that resulted in 3D computer models where we could prove that the mix, the blend of radiation is completely present in the whole device. And that allows us to protrude and enter small cavities of objects being put inside.
All right, thank you very much. The floor is yours, guys, for your questions.
Duncan, thanks for presentation. Fascinating stuff you're having. Tell us what's your priority markets, which you want to get, what countries, and what are your priority segments in those markets you're looking for?
Yeah, well, our technology is very of great interest for infection prevention specialists. So medical distributors who are active in the domain of infection prevention, that is a good match. In Belgium, we have found a two-tier distribution setup. We have one partner who is focusing on infection prevention, and we have one distributor, one partner who's focusing on the dental market. And those are two separate markets. And this is more or less the scope we are looking for on international scale. I hope this answers your question.
Perfect. And I'm very happy to follow up with you following this affair.
Yeah, I see two questions popping up in the chat. If you allow me to answer those.
Perfect, Duncan. Thank you very much.
Yeah, the maximum size of objects which can be disinfected, our device right now has a maximum size of, as I said, it's about 25 by 35 centimeters and 8 centimeters in height. So a small size laptop can be put inside. And jumping to Jean-Pierre's question about probes. Probes are very specific and long. We have a development track already for a few months ongoing, where we are going to build a special UVC radiation device built to disinfect probes, because that's a demand we have heard over the last weeks and the last months very, very clearly. Probes are difficult to disinfect, but there are some challenges to overcome. And it all has to do with trying to combine water as probes are cleansed before they go into disinfection. So we need to make sure that our LEDs also get a protection against humidity and water, which is not so easy to do. Why? Because UVC radiation, and I didn't mention this in my presentation, on Earth, there is only one material which is able to transmit UVC radiation, and that is a very specific quartz glass. So if you come across UVC radiation devices in the market who do not have a quartz glass carrier to put the objects on top, then you have to question the results. So quartz glass is the key to build a UVC disinfection device.
Thank you.
Thank you, Duncan. Duncan, if you would have a solution in the future for probes, feel free to reach out. You can get my contact details through Christoph or the network, because we might have some opportunities. It's Benelux, but feel free to reach out.
I will do so. Thank you.
Also, there's one more question, Duncan, in the chat actually from Manuel, asking, what about the base of the object, which has to be placed in the cabinet?
I'm not sure if I understand the question right. So any object put inside our cabinet is put on top of this quartz glass plate, as I just explained. Mm-hmm. So it doesn't really matter what is put inside. The radiation goes from the bottom, from the top, all around. Yeah.
All right, thank you.
Yeah, and I see a question from Dennis. Can a surgical instrument, can be re-sterilized besides the operation room with your system? We are very clear, open and honest about this. Our technology is disinfection. We cannot claim the word sterilization because for the moment, sterilization is the playing field of temperature, 134 degrees heat, steam, etc., etc. And the legislation in Europe does not allow us to use the word sterilization. In the US, it's a bit different. In the US, there is a general acceptance that log 6 reduction, meaning a 99 and 4 nines behind the comma, is considered as sterilization. We do achieve these disinfection levels, but in Europe, we can't call that sterilization. So we are a bit cautious about using the right terminology So that means that we are talking about disinfection. Can a surgical instrument be used besides the operation room? Yeah, of course, you can put a surgical instrument inside, but we need to evaluate how the surgical instrument looks like before giving it a green light. Why is this? It's already been mentioned. Cavities, imagine hollow tube. Our UVC radiation can only enter the surface. A hollow tube at the inside will not lead to the actual results. So this is why surgical instruments need to be validated by us first before they can be used.